Want to create your very first iOS app, but not sure where to start? Well, you're in the right place. Let's get started. In this tutorial, we will start to create the bricks and the paddle. So the first thing we need to do is to create a new SwiftUI file. Hold down the Control key, left click on the mouse, and then select New File. Select SwiftUI View, click on Next, and call the file breakout. Game View. Within the new created view, we will add some @state variables. So after lines 10, enter the following: @state private var balls ball position CG point X 200 Y 400. Velocity is the CG size. Width and height. So the width is 4 and the height is -4. So the purpose of the @state variable on line 11 is to set the position of the ball and the speed of the ball using the velocity that we'll implement later on. @state private var paddle equals paddle. Position CG rec X 150 Y 500 width 100 and height 100. No, height is 20 pixels. So the purpose of lines 12 is to create the paddle. We have a width of 100 pixels and a height of 20 pixels. Next thing we need to do is to create an array of brick objects, and also create an array of power-ups objects, line 13, we need to include the word var or the keyword var to declare the variable var. We also need to create an array of particles to have a particle effect. The particle objects or the class, it doesn't exist as yet. So yeah, we can just create it now. So let's create another file, which is a Swift file. Name the file particle. Struct particle identifiable. So particle has an ID, unique ID, has a position, CG point, which is the current position of the particle on the screen. It also has a velocity that includes the direction and the movement and speed of the particle, which will be CG size. Var size, which is the size of the particle in radius, which will be CG float. Var color, which is the color of the particle. And then var opacity, which is double. And this is the opacity of the particle as in transparency level. So we need to go back to the breakout game view. And I missed that bargain. Keep on doing that. Enter the following at state private var game timer, which is optional, and that's a time loop for the game. At state private var score, which is 0. At state private var lives. The player has 3 lives to start with. At state private bar game over equals false. At state private bar level is 1. Each time when the game starts, it always starts from level 1. At state private bar paused equals false, which will enable the user to pause the game. At state private bar magnet active, which is false, and that's a magnet power up state that we'll implement later. At state private bar reverse controls, which is false. And then we need we need a constant, which is called number of columns, which is equal to 6. We can delete line 28, we don't need it. Add our geometry reader. Within our geometry reader, we will add our V-stack, and then we color our V-stack using a black color. Whilst ignoring the safe area. And then we loop through each of the bricks using a for each. If not, brick is hit. So we create a rectangle for the brick, and then we fill the brick with color. We need to create a new function called brick color that will return the correct color for the brick. Private function brick color for brick. Brick. And then that returns a color object. Switch brick dot type. If the brick is a normal brick, then just return blue for the color. If the brick is a multi-hit brick, return orange. If the brick is a power up, then return a purple brick. If a brick is an explosive type brick, then return red. And then if the brick is just moving, then the color will be a cyan brick. Oh yeah, there's another brick I've forgotten to include, which was that's correct for the brick color function. At the moment, we don't need any more cases. So the next thing we need to do is to go back to line 36. And then we add the following: dot frame, so we set the frame for our brick. So the brick has a width, brick dot position, width, height, brick dot position, height, position x, brick dot position dot mid x, y, brick dot position mid y. And then to animate when a brick has been hit, we just use dot ease in, and then set the value to brick dot is hit. On line 37, we can remove the full stop, that's not needed. The next thing we have to do is to draw the paddle so that the user can move left to right. We use another rectangle. Dot fill. Magnet active. So if magnet is active, then the color will be cyan, else it will be red. Frame, width, paddle, position, width, height, paddle, position, height, and that sets the paddle size. The next thing we need to do is to set the position of the paddle. Paddle position mid X, Y, paddle position mid Y. And then we will also, there should be a full stop at the beginning of line 46. We should also animate the paddle movement, so we need to use dot animation, dot ease out or ease in out. The value will be paddle dot position. So the next thing we need to do is to create the falling balls. For each balls dot indices ID self index in and it should be on line 49, it should be balls with an S at the end, not ball. So we need to also implement the trail of the ball. For each balls index dot trail indices ID self trail index in. That's within the closure. So to create the ball, we need to use a circle shape, and then we fill the circle with the color white, opacity 0.3, dot frame, width 5, and height is 5. And that sets the trail circle size. And then the next thing we need to do is to position the trail circle. Trail index, we'll just compile it to see if there's any errors. Cannot find color. Import SwiftUI. So we need to import SwiftUI into the particle file so that the color can be found, or so that the namespaces and imports can work. So the next thing we need to do is to create another circle on line 57, anywhere after line 57, 58, it's up to you. And then we fill the circle with a green color. The frame 20 and the height 20. That sets the ball size. And then the position of the balls, or each of the balls using the index. Just compile it again. In next week's tutorial, we will implement some of the particle effects. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.